So good evening everyone. In this video today I am going to explain some of the questions of the subject database management system. So just let's straight on jump to the questions. The first question is, in a relational data model, which one of the following statement is true? Here four options are given to us. A is a relation with only two attributes is always in BCNF, and we already know this is the only correct answers. And rest all are incorrect, as if second is if all attributes of a relation are prime attributes, then the relation is in BCNF, which is obviously false, because if all the attributes are prime attributes, then it will always be in third normal form and not generally in BCNF. Similarly, C and D are also false. So next is, okay, so the next question is, consider a relation R A B C D with the following three functional dependencies: A B C B C relates to D, C relates. The number of super keys in the relation R is, so if we find the compute closure of this attribute, AB plus gives us ABCDE, BC plus gives us BCDE, C plus gives us CE. So only one candidate key is possible for the given relation, that is AB. And the formula for super keys of the relation is 2 raised to power total number of attributes in relation minus total number of attributes in each key. So here the relation with AB plus gives us 5 total attributes, and and subtracting the number of attributes in the key R2, which is AB. Therefore the final result gives us 2 raised to power 5 minus 2, that is 2 raised to power 3, that is 8 keys. Therefore the answer is 8. So the second question is, a relation R is A comma B in a relational database has 1200 tuples. The attribute A has integer values ranging from 16 to 20, and the attribute B has integer values ranging from 1 to 20. Assume that the attributes A and B are independently distributed. The estimated number of tuples in the output of sigma A is greater than 10, union B is equal to 18 is. So in this question we need to find out the probability. The probability of A would be A greater than 10 would be 10 by 15, as it is given that the integer values are ranging from 6 to 20 in attribute A. So the probability will come out to be 10 by 15 equals to 2 by 3. Similarly for B it would be 1 by 20. And to find out the union of this by Dbms theorem, it would be independent probabilities sum minus subtracting the intersection of both the probabilities, which gives us the final answer 41 by 60, and the estimated number of tuples would be 41 by 60 into 1200 equals to 820. But we need to negate the duplicate tuples which are not allowed in the relational algebra. Therefore, number of unique tuples would be 15 into 20, as A has 15 integers and B has 20 integers, which gives us 300, and then multiplying it with the 41 by 60 gives us 205. Therefore, the estimated number of tuples would be 205. Okay, so this question is whether the set of functional dependency F is equal to QR implies S, R implies P, S implies Q, hold on a relation schema X equals to PQRS. It is not a BCNF. And this question has two statements following: both Y and Z are in BCNF, and second is decomposition of X into Y, and Z is dependency preserving and lossless, which is the following statement is are correct. So after gaining knowledge about this topic, the conclusion I come to is the answer would be A. That is second statement is only correct. Cause here's the explanation. The decomposed relation Y, P, R and Z, Q, R is satisfying the dependency implies P and Q, R implies S, S implies Q respectively. Relation Y is in BCNF, but relation Z is not in BCNF, because in S implies QS is not a super key. Therefore, all the dependencies of the relation X satisfying on relations Y and Z, so it is lossless and dependency preserving. Okay, this question number 3. Consider a relational variable R that is in third normal form but not in BCNF. Which one of the following statements is true? So the answer would be D. R has a non-trivial functional dependency X, A, where X is not a superkey and A is a prime attribute. So this would be the answer of this question. D. Okay. So this question, which of the following functional dependency holds for relation R A comma B comma C and S B comma D comma E? B implies A implies C. So so the relation R contains 200 tuples and the relation S contains 100 tuples. What is the maximum number of tuples possible in the natural join R natural join S? So the answer would be 100. And here's the explanation. So the explanations from the given set, the functional dependencies, it can be observed that B is the candidate key of R. So all 200 values of B must be unique in R. There is no functional dependency given. There is no functional dependency given. So the target two for to get the maximum. So therefore the answer would be 100 of this question. Moving to the next question. Assume that the supplier's relation above the each supplier and each street within a city has a unique name. And S name comma city forms a candidate key. No other functional dependencies are implied other than the implied by primary and candidate keys, which is the following is true. So the answer would be 1. The schema is in BCNF. A relation is in BCNF if for every one of its dependencies X, X or Y, at least one of the following conditions hold. Hmm. So the answer of this question is 1. The schema is in BCNF. Next question is, which one of the following is not a part of ACID properties of database transaction? Atomicity, consistency, isolation, deadlock freedom. So the correct answer is deadlock freedom. And here's the here the definition of each of the following terms is given. Atomicity is nothing but the entire transaction takes place at once or doesn't happen at all. And the data was must be consistent before and after the transaction. Isolation is multiple transactions occur independently without interference. Durability is the changes of section transaction occurs even if the system failure occurs. So the correct answer would be deadlock freedom. So moving to the next question, a database of research articles in journal uses the following schema. So here is the question, and these are the options of this question. So the correct option of this question would be second, that is second normal form. And here's the solution given, describing the unique attributes of each of the normal form. And by studying every attribute of every normal form, we conclude that the answer would be the second normal form of for this question. Okay, so this question is from GATE 2015. The question is, consider the following transaction involving two bank accounts X and Y. Read X. X equals to X minus 50. Write X. Read Y. Y is equals to Y plus 50. Write Y. The constraint, the sum of the accounts X and Y should remain constant is that of. So the answer is consistency, obviously. Because for the constraint that the sum of the accounts X and Y should remain constant, it can only be maintained through consistency. Neither of the three options could make the sum remain constant, and only consistency can do that. Okay, so the next question is, consider the relation X, P, Q, R, S, T, U. Which of the following set of functional dependencies F, P, comma R implies S, comma T, P, S, U implies QR. Which of the following is a trivial functional dependency in F plus, where F plus is the closure of F? So these are the options, and the correct option is C. P comma S implies S. This is the only trivial functional dependency in F plus, where F plus is the closure of F. Um, Moving to the next question. So the next question is given the following two statements S1 every table with two valued attributes is in one first normal form, second normal form, third normal form and BCNF. And statement 2 is A, B implies C, D implies E, E implies C is a minimal cover for the set of functional dependencies. A, B implies C, D implies E, A, B implies E, E implies C. Which one of the following is correct? So upon having the look on all the options, the correct option is A, S1 is true and S2 is false. This is the answer of this question. Let's move to the next question. The maximum number of super keys for the relation schema are E, F, G, H with E as the key is. So the explanation is also given here. So it tells that a super key is a set of attributes within a relation schema such that no two distinct tuples can have the same values for those attributes. So upon having the above condition applied, the possible combinations are E alone, E with one additional attribute, and E with two additional attributes. Basically, applying all the permutation and combinations with E, we can come to the conclusion that all the possible combinations could be 8, as it is given four attributes are there, and all on applying the permutation formula, the answer comes out to be 8. Therefore, the question's right answer would be 8. So let's move to the next question. Next question is the following functional dependencies hold for a relations R, A, B, C, and S, B, D, E. So the relation R B implies A implies C. The relation R contains 200 tuples and the relation S contains 100 tuples. What is the maximum number of tuples possible in the natural join RS? So as we know that in a natural joint every tuple should be unique and repetition isn't allowed in the natural join. Therefore, 100 would be the right answer of this question. That is option number A. The next question is assume that in the supplier relation above each supplier and each street within a city has a unique name and S name, city forms a candidate key. No other functional dependencies are implied other than those implied by primary and candidate keys. Which one of the following is true about the above schema? So the correct option of this question would be A. The schema is in BCNA because as we see each supplier and each street within a city would have a unique name. Therefore, SID street city implies S name. S name comma city forms a candidate key, so that S name city implies SID street. SID primary key SID is a primary key, so that SID implies S name city street. S name city street. Therefore, each of the functional dependencies shown above are satisfy BCNF. Therefore, the answer would be A. The schema is in BCNF. Let's move to the next question. That is